Welcome in our next class of algebraic expressions. And this time now we are going to look at substituting positive number into algebraic expression. As we have seen earlier on, we've seen algebraic expression consists of terms which have pronumerals and constants, or it has got variables and constant. This time now, we don't want to have the variables or what we call pronumerals, but substitute so that we can have a value of the whole expression. Now, in most cases, for example, when we evaluate a number like 4x, let's give it a 4 plus x. This is simply an expression. Now, in this expression, if we had a value for x, like given that x is equals to 11, then it means that at a place where we have x, we shall write there 11. So we shall substitute. That's what substitution means. Then we have 4 plus 11. Now this one, when we look at this, it's just numbers and we are adding integers, which gives us the value of 15. And in this, you realize that we only have a constant. We no longer have the pronumeral, simply because we have substituted its value with the numbers that we were given. So this is what we call substitution. So let us look at what exactly the procedure that we need to do or to have while substituting in expressions. So what is this that means substitution or to evaluate? To evaluate or to substitute values. To evaluate or to substitute values simply means to replace the pronumerals in an expression. To replace pronumerals, that is the values of letters or the variables, with the exact values that we've been given. Now, I want us to look at this example, and then we see how do we evaluate. Remember, to substitute or to evaluate in this particular case is to replace the pronumerals with numbers. Now, here we are. If x is equals to 3 and y is equals to 8, find x plus 2y. Find x plus 2y. Now, you'll notice that in this particular expression that we have here, it is an expression, but the pronumerals here have been given or have been assigned values. So what it implies that we shall come and replace the value. So where we have an x, we shall write a 3. So we shall move ahead and say this is the equivalent to 3, then plus 2. 2y is the same as 2 times y. But what is the value of y? The value of y is 8. So we rewrite this and have 3 plus 2 times 8. Taking you back to the order of operation. The order of operation says that after the bracket we move to division and multiplication starting from the left, and then addition and subtraction. Now, the one that follows here is the multiplication, which means we shall first resolve 2 multiplied by 8, and then we add 3. So this one becomes 3 plus 16, which gives us 19. We have 19 And initially we had an expression of x plus 2y. But since we had the value of x, we had the value of y, then those variables were substituted. That is when we had 3 in place of x and 8 in place of y. That is what you call substitution. We all know this. We all know that 4a is the same as 4 multiplied by a. That is very true. However, given the constant values, for example, 42 is not the same as 4 multiplied by 2. So we only substitute and multiply when we have a constant and a pronumeral, but not when we have a constant and a constant. And also when you are substituting, giving an example here, if you have, like earlier on, we had 2y and y, where y was 8. Take note very clearly. You do not substitute by writing, here 2, 8. This one here is wrong. Why? Because this is a product. It's a multiplication. So you will first come and say 2 multiplied by y, and then you now bring in your substitution, and now it will be 2 multiplied by 8, which gives us 16. So I'm saying that it is true 4a is 4 times a, but it is not true that 42 is the same as 4 multiplied by 2. We should observe that rule while substituting the pronumerals in an expression. Now, the rest that follows in substitution and of expressions is the real order of operation. And when we talk of the order of operation, now, when you talk about the order is deal with the brackets, then come to the division and multiplication from the left to the right. We have always seen that. From the left to the right. Then we come to the addition and subtraction again, the order from the left to the right. So the rest of the operation, just the way we do it in fractions, the way we do it in integers will remain and will always apply. What is very important in this particular part is how we carry out the substitution and how we move on. But after substituting, the order operation remains the same. So let us start looking at various questions and examples that will help us understand how to carry out substitution in an algebraic expressions. given that t is equal to 5, evaluate t plus 7, 8t, and 10 over t plus 4 plus minus t. So we shall start with the first one. This is about substitution, so we shall maintain. So t plus 7 is an expression, but t is equals to 5, which means in place of t, we shall put there a 5. So we shall have this as 5 plus 7, which gives us 12. So we no longer have t, but instead we have 5. This is a normal problem that we can simply work out. We add and we get its answer. Second part, we have 8t. As I said earlier on, to substitute, we don't just go in substituting directly. Let us know the meaning of the expression here. So this one is the same as 8 multiplied by t. Having written now this, you can now move ahead and do the multiplication and substitution. So this one here is the same as 8 multiplied by, instead of t, we shall put there 5, because t is 5, which gives us 40. I want you to notice this, that we broke first by multiplying this, but not by simply saying 8t. If t is 5, then we say 8, 5. This one is wrong. It is wrong. We do not substitute this way, but we break it by first showing the meaning of 8t is the same as 8 multiplied by t. On the last one here, we have 10 over t plus 4 plus t. But remember, t is equivalent to 5, so we are going in to do the substitution first and then proceed. So rewriting as we substitute, it is 10 over t, but t is what? T is 5. So we put a 5 plus 4. 4 is a constant. We maintain it. We have a 4, then minus t. T is 5, so we bring in 5 there. So we now have all of them as a fraction, and others are numbers. 10 over 5, 5 goes into 10 twice, so we shall have this one equivalent to, this by 5, 1 by 5, 2. This is 2 plus 4 minus 5. In our operation from the left, we move to the addition first. So this one will give us 2 plus 4, which is 6. 6 minus 5, which is 1. We shall find that the value of 10 over t plus 4 minus t is simply equals to 1. Now, let us look at questions involving multiple numerals or several pronumerals. And this one now, let us look at the question that follows. question that we have here is substitute x is equals to 4 and y is equals to 7 to evaluate these expressions. The first expression, 5x plus y plus 8. And the second one, 80 minus into bracket 2xy plus y. Now we say here that we have multiple pronumerals. That is, we have several unknowns or variables. In the first case here, we have two unknowns. We have got x pronumeral and we also have a y pronumeral. So we shall first rewrite this by its meaning, which is 5 multiplied by x, then plus y, then plus 8. Now, in substituting, where x is 4, so we shall rewrite here as 5 multiplied by 4 plus 5 multiplied by 4 plus y, but y is 7. We put there a 7, then plus 8. Now, the order of operation should be maintained. So we deal with multiplication first before others. So this one will give us 20. 20 plus 7 plus 8. So when you work out this one, this is 20 plus 7 gives us 27. 27 plus 8 gives us 35. So we have been able to find the value of 5x plus y plus 8, given that x is 4 and y is 7. Now, having substituted here, for the next one, let's see what we shall apply there. The value of x and the value of y remains 4 and 7 respectively. And our expression reads 80 minus into bracket 2xy plus y. Substituting those values will require that we first have to know or to interpret what xy means. 2xy means what? As we said earlier on, we don't just carry the values and place them there. So we shall rewrite this and we shall find that it will be 80 minus inside the bracket, it is 2 times x times y and then plus y. I've broken this so that we don't make a mistake of bringing in the values without knowing its meaning. Substituting, we shall rewrite, we have 80 minus into bracket, it is 2 multiplied by x. X is 4, I bring in 4, multiplied by y. Y is 7, bring in 7, and then plus y, and y is also 7. Now here, as we said earlier on, the order of operation of bracket should be follow. So we need to resolve what is inside the bracket. But even inside the bracket again, we look at the order of both division, subtraction, addition, and multiplication. So we shall need to deal with multiplication first from the left, and then we move on to the other. So meaning that we shall first resolve this first part inside the bracket, which is 2 times 4 times 7. When you multiply 2 times 4 times 7, you will get 56. So this one will be 80 minus inside the bracket 56 plus 7. 56 plus 7. Now, if you have that, 56 and 7 is still inside the bracket, so you'll resolve that one, you work out that one. 56 plus 7, you'll find it is 63. So this one becomes 80 minus 63. When you subtract this one, you find your answer as 17. So we have been able to substitute the values of x and y in this expression to get 17. And also we've been able to show that the order of operation must always be obeyed. And that's what we get. Now, I want us to go into a slightly advanced level of substituting with powers and roots. You have only seen we're substituting when you have either the product of pronumeral and a constant and so on, or pronumeral and another pronumeral. But now, when we bring in powers, how do you substitute with powers and roots? Now, we are going to deal with powers and roots. If P is equals to 4 and T is equals to 5, find the value of A, 3P squared, or 3P power 2, and B, T squared plus P squared, C, root of P squared plus 3 squared. That's our question. We have the question for the roots. We have others as powers. So let us look at the first one. And before we move on, we need to first understand. When we have a power of a number, when we have a number or a letter or a pronumeral raised to a certain number, what does it mean? So let us first understand that before we come to resolve this. As we saw earlier on, we saw that when we write a number like A raised to power 2 is the same as simply multiplying that number by itself 2 times. If we had A raised to 4, it will mean that we are going to multiply a number by itself 4 times. So this one will be equivalent to A times A times A times A. How many times? 4 times. So this is the case. So the moment you start seeing the powers, put in mind that it is that particular number or that particular pronumeral or variable multiplied by itself, and the number of times is equivalent to the power that we have. If it is 2, it is 2 times. If it is 4, it is 4 times. So in this particular case now, when we come back to our question, the question reads 3P squared. 3P squared. As we saw earlier, 3P can be the same as 3 multiplied by P squared. It's not the end. We move ahead. This is P squared. What does the rule say when a pronumeral is raised to the power of 2? So we rewrite this and say it is the same as 3 multiplied by P multiplied by P. Now we no longer have the powers. We no longer have any number raised to anything, but now we can just multiply. So if that is the case, we now come in and substitute. P is equivalent to what? To 4. So this one becomes 3 multiplied by 4 multiplied by 4. So this one here, if we are to multiply now like that, you'll find that it becomes a bit easier because they are just numbers. So this one gives us 3 times 4 is 12. 12 times 4 is, this one is equals to 48. For the second part, we have the powers and then we have an operation of addition as a symbol and another pronumeral raised to the power of 2. So as we saw earlier, we don't just move ahead substituting it quickly, but let us know that T is equivalent to a number. So this is the same as T multiplied by T plus P times P. So we have those areas. So P, T times T plus P times P. But T is 5, so this one will be 5 multiplied by 5 plus P. P is 4, so 4 multiplied by 4. The order of operation says we deal with the multiplication for this particular case from the left. The first multiplication is here. The second one is here. So those are going to be two operations first before we wind up. 5 times 5 is 25 plus 4 times 4 is 16. So when you multiply, when you add, getting the sum of these two here, you'll find that your answer is going to be a different number. Now, when you look at this is 16 and this is 25. So we are going to add 25 plus 16, which will give us 41. It will give us 41. So what do we realize here? We realize that it has been easier for us to handle this because we dealt with the first operation on the left and then moved on to the other right. The last one, which requires a large space, we have been asked for the root of p squared, plus 3 squared. Now, as you can see that, if we rewrite that, it is the same as simply writing p times p plus 3 multiplied by 3. That is what it means. So we have got only one pronumeral, which we are going to substitute. On substituting this, we shall find that the value of p that we have is going to be substituted with 4. So we'll have the root of 4 multiplied by 4 plus 3 multiplied by 3. As much as these are inside the root, but the rule of the operation still applies. So we shall deal with the multiplication from the left before we move ahead to find the root. So 4 times 4 is 16, and 3 times 3 is 9. So which implies that we are going to look for the root of 25. And if you can use your calculator or your mental arithmetic, you'll find that the root of 25 is always equals to 5. The root of 25 is always equal to 5. So that is it when we are going to, when we substitute powers and root, when we are substituting with the powers and roots given the algebraic expressions. So you find that in general, algebraic expression obeys the rules of any mathematical term that exists or operation where we have the roots, where we have the powers, they'll always be there. Remember, this is just by itself, this is a term. Now, let us look at further enrichment questions touching on various questions that will involve substitution. As you have seen, when you substitute a pronumeral, you remain with a general expression of either a mathematical operation, like maybe it's simply addition or subtraction or multiplication of integers or division. So I'll first look at the order as we review what we did earlier, the order of operation, how we shall approach it as we go further to substitute. Now, let's start with this. We are to use the correct order of operation. 4 plus 2 times 5. 4 plus 2 times 5. It is illogical to say 4 plus 2, which gives us 6, and then multiply by 5, and then you say 30. This one is wrong. Why? You didn't observe the order. So the order must be obeyed. So the first thing to be dealt with here, we don't have division, so it's going to be multiplication. And then we move ahead. So we shall find that this particular question, we shall have it as 4, then plus the product of 2 and 5, which is 10, and find your answer as 14. For the second one here, as we saw earlier, the order is that we deal with the bracket first and then the rest follows. So the order here is, inside the bracket we have 7 minus 3. Outside the bracket we have times 2. So as much as we talk of multiplication coming in first, but bracket must always prevail. So we deal with the brackets here, which is 7 minus 3, and then we multiply by 2. 7 minus 3 will give us a 4, and then multiply by 2. You find that your answer is simply 8. So we must observe the order every time we are working out a set of operations. Now, having said that, let us look at the following problem. What is the result of evaluating 10 minus u if u is 7? 10 minus u if u is 7. This is a straightforward question. You substitute directly. Where we have u, we put a 7 and work out. So this one will be the same as 10. Subtract the value, the u, and u is 7. So what remains is 3. So you have been able to substitute u, and you have your answer as simply 3. So given any values of a pronumeral, we can always substitute, especially when you are adding and when you are subtracting. But now let us look at further substitution, which involves further order of operations. If x So we have, if 5, x equals to 5, evaluate a, 2 into bracket x plus 2, close the bracket, and then plus x, and 2, 20 over x plus 3. Now, this expression involves one pronumeral, and that one pronumeral that we have is x. As much as x appears here twice, it is just one pronumeral that we require. Now, if x is 5, if we are to substitute this particular part, x is 5. So it will mean that we rewrite this one, we shall maintain a 2 outside the bracket. X is 5, we put a 5, then plus 2, close the bracket, and then plus x, but x is also 5, maintain 5 there. Now, we shall not start multiplying or removing the bracket, but we deal with what is inside the bracket first, which is 5 plus 2. So this is the same as 2 multiplied by 5 plus 2, which is 7, and then plus 5. Using the order again, we shall resolve here first before we add 5. So 2 times 7 is 14, and then plus 5. So you find that here our answer becomes 19. So we are able to simply substitute and maintain the order of operation. In our second part, the second part that we have here, 20 over x plus 3. 20 over x plus 3. Here, you'll find that the value of x is 5. We substitute it in, and you'll find that we have 20 over x, then plus 3, but x is 5, so instead of x, we shall have a 5. So when we have a 5, 5 is divisible into 20. 20 can divide 5, so by 5 here is 1, by 5 here is 4, we remain with 4 plus 3, which gives us a 7. So this is when it involves one pronumeral. Now, let us introduce a question where now we have a denominator which is not a single pronumeral or a single number, but simply an expression just like the rest up. So if x is equals to 5, evaluate 6 into 3x minus 8 over x plus 2, over x plus 2. Again, the same way, if x is 5, we go ahead and substitute, and what we shall have, it will be 6 into, this one is 3 multiplied by x, then minus 8, and then we divide by x plus 2. And remember, I'm separating this so that we don't have a problem when we substitute. Substituting now, we shall have 6 into 3 multiplied by x, but x is 5, so put a 5 here. Then minus 8, close bracket. The denominator, we have x minus 2, and x is 5 minus 2 is there. Now, inside the bracket, we maintain the rule of operation where we deal with the multiplication in this particular case first. So it will be, what we shall have here, it will be simply 6 into 3 times 5, which is 15. So 15, then minus 8, close bracket, and the denominator is 5 minus 2, which is 3. When you have that, we remove the brackets, by which will mean 6 multiplied by 15 minus 8, which is 7, divided by 3. So we can simplify, or we can calculate and then simplify later on. By 3 here is 1, by 3 here is simply 2. 2 times 7 is 14. So we find that all these expressions we have, when we substitute and work it out, we shall find our answer reduced to 14. Now, let us bring in now 2 pronumerals or more and try to see what happens. if A is equals to 2 and B is equals to 3, evaluate 1, AB minus 4 plus B, and B 2 times inside the bracket we have 3A plus 2B. Starting with the first one, where we have this AB, we said earlier on that AB is the same as A times B. So we write it as A times B and not AB. So it will be A times B, then minus 4 plus B. Substitute the value of A and the value of B if we are given. And A is 2, so we have 2 times B, and B is 3, minus 4, then plus B, B is 3. We shall deal with the multiplication first. 2 times 3 is 6, minus 4 plus 3. Now coming here, when we deal with addition and subtraction, we normally start, it is dealt with, but from the left, either addition or subtraction. What we have here is just addition and subtraction. So we shall take it easy and just work out 6 minus 4, which is 2. 2 plus 3 gives us 5. So from the left, this one will give us 2x, 6 minus 4, which is 2, then 2 plus 3 is 5. So we shall find our answer in this particular question as 5. For the second part, we have inside the bracket, so we shall deal with the bracket first. For the bracket, we have the product of 3A, so we have to rewrite. So this is 2 multiplied by 3 times A plus 2 times B. 3 times A plus 2 times B. Substituting the values, we shall have 2 times 3A, which is 3 times A is 2, plus 2 times B, and B is 3. That is what we have. Inside the bracket, we deal with multiplication first from the left, and that is what we have. This is 2 times, in bracket, 3 times 2, which is 6, and 2 times 3, which is 6. So we find that we are adding what is inside the bracket. This is the same as 2 times 12. That is the sum of 6 and 6. So 2 times 12 gives us 24. It gives us 24. So we have been able to solve or evaluate a question involving 2 pronumerals given their values as we substitute. Now, I want you to note that it is not always that we are given the values of our pronumerals or variables in terms of 1s, 2, and so on. We can be given it as a 0. So when we are given as a 0, we should not assume that value, but we should see how do we approach a value where we have been given or the pronumeral has been assigned its value as a 0. Let us look at this question here. Evaluate the expression for x plus y. X plus 2y if so we have one expression which you are going to evaluate as we substitute, but using 2 different values at any given time. So the first part, we shall use the value of x as 0 and the value of y as 4. So first part, we look at that. If it is 5x plus 2y, which is the same as 5 times what? Times x plus 2 times y. So substituting the value of x, this is the same as 5 multiplied by x, and x is 0, plus 2 multiplied by 4. Now, when you look at a number multiplied by 0, it's always a 0. So it will be 0 plus 2 times 4, which is 8. This one gives us 8. Gives us 8. So 0 multiplied by a number is just 0. And when you have a 0 in front, it's just insignificant. It will always not give us any value. It's insignificant. That's why we have 0 plus 8 as 8. You can still look at the same when the value of y is 0, but the value of x is 2. Maintaining the same expression, 5x plus 2y. Now, this is the same as 5 multiplied by x. When you multiply 5 by x, then also 2 must be multiplied by y. But what's the value of x here? The value of x here is 2. So 5 times 2 plus 2 times y, and y is 0. So you'll find that this is 10 plus 0, which is equals to 10. So you'll realize that anytime a constant is multiplied by 0, it will always be a 0. And we have been able to work out and substitute the values in an expression, given that the values are 0 and the other value is a number. So let us complete this table to understand further. So we have this question where now we are expected to use the knowledge you have gone through and be able to fill this table correctly. Copy and complete the table. The first table is B, and below B we have 2 in bracket B minus 1. Now, in this first row, B is 1, 2, 3, up to 6. Every time we have the value of B as 1, we should be able to get the value of 2 in bracket B minus 1. And then we fill it here. For example, for the first part, to illustrate the first part, now I'm illustrating this. If b is 1, what is the value of 2 in bracket b minus 1? This one here will mean we shall take 2 into b, and b is 1 minus 1, right? Are we right there? This is 2, b is 1, so we have 1 minus 1. 1 minus 1 is 0. 0 times 2 is 0. So the first box, we shall fill it with a 0. Because 1 minus 1 is 0. 0 times 2 is 0. Let us move to the second part here. Given that b is 2, what will be the value of 2 into b minus 1? So it will mean that here it will be 2 into b, but b is 2 minus 1. So 2 minus 1 is 1. 1 times 2 is 2. So if that is the case, then the value here, it will be 2. So when b is 2, then 2 into b minus 1 is also equals to 2. When b is 3, then we shall substitute and say it is 2 into 3 minus 1. 3 minus 1 is 2. 2 times 2 is 4. So in that box, you go and fill in a 4. When b is 4, it will be 2 into 4 minus 1. This one will give us 4 minus 1 is 3. 3 times 2 is 6. So you go and fill in here a 6. For 5, it is, for 5, we shall say 5 minus 1, which is 4. 4 times 2 is 8. So in that box, we shall fill 8. And finally, when it is 6, it is 6 minus 1, which is 5. 5 times 2 gives us 10. Now, using algebraic knowledge of substitution, we've been able to fill this table. The same applies in this other table. The same applies in this other table. So if q is 1, then 10q is 1 times 10, which is 10, minus 1 is 9. So I'll expect this part to have a 9. If I may repeat, 10 times 1 is 10, then 10 minus 1 gives us 9. If q is 2, then 2 times 10 is 20. 20 minus 2 is 18. So I'll have 18 there. If it is 3, it is 3 times 10 is 30. 30 minus 3 is 27. This part I'll have 27. If it is 4, 4 times 3, 4 times 10 is 40. 40 minus 4 is 36. For the 5, 5 times 10 is 50, and 50 minus 5 is 45. And lastly, 6 times 10 is 60, and 60 minus 6 is 54. So all the way we are able to fill through across this table because of being able to substitute the values of q as it moves between 1 and 6 across the board. Now, to wind up, I want to say this, that it is very important for us to know how to substitute values and substitute them correctly when we are dealing with algebraic expressions. And that is why in our daily lives, it's always easier for us to work out, when, especially when you are given somebody like working at a certain rate, and the rate is given in terms of a pronumeral, simply because several people do not work at the same rate. That's why we put a pronumeral maybe to show a number of hours. So when you are given 5 hours, we go in and substitute. When you are given 10 hours, we go in and substitute. But in all the substitution we have seen that it always reduces itself to an ordinary expression of integers, the operation of integers, where we observe the rule of order of operation. So it's very necessary that when dealing with algebraic expression, especially substitution, always put in mind the order of operation must always prevail. So that is it in our today's class. In the next class, we shall be looking at equivalent algebraic expressions. Thank you.